Hello students, in this video we'll see an example of finding conditional variance. Let's suppose that x and y are jointly distributed with joint PDF proportional to f of xy is x over y plus 1 on the region y goes between x squared and 1, and x goes between 0 and 1. Let's find the variance of x given that y is equal to a fixed value, little y. So to do this, let's plot the region first. So we'll plot our region. Here's the x-axis, here's the y-axis. Here's y equals 1. And here is y equals x squared. Check it over here. So this is our region of integration. So y goes from x squared, that curve, all the way up to 1. And so what we need to do is we need to find the conditional density of x given that y is equal to little y. So fx of y equals little y of x given y is equal to the joint PDF over the marginal PDF. So this will be a dx integral, f of xy. Now we need to figure out where x goes from in this region. Well, in this region, x goes from 0 all the way up to this curve over here, and that curve is going to be y equals x squared. So this curve over here, what is x equal to on that curve? X is equal to the square root of y on that curve. So x goes from 0 up to the square root of y. And so now what we have over here is we're going to have x over y plus 1 over. Now we'll integrate this and get x squared over y plus 1 times 2, evaluated from x equals 0 to x equals root y. And so what we'll get over here is we'll have x over y plus 1 over, if I plug in the y squared, I'm going to get a y over y plus 1 over 2. And so if we simplify this, the y plus 1s are going to cancel. And what we're going to have over here is we're going to have, and this 2 in the fraction will go on top. So what we're going to have is we'll have an x, 2x over y. So 2x over y is our conditional density function. And this, of course, is valid if y is between 0 and 1. Now we need to find the variance of x given that y is equal to little y. So let's do that. So the variance of x given that y is equal to little y is the expected value of x squared given that y is equal to little y minus the expected value of x given that y is equal to little y quantity squared. So we have to do each of these terms separately. Let's call this first term over here 1, and the term inside the square 2. And now let's compute these things. So let's compute 1 first. So 1 is the expected value of x squared given that y is equal to little y. And that's going to be the integral of x squared, that's the function we're integrating, times the joint, the conditional density function, which is 2x over y. I'm going to do a dx integration. Now where does x go from in this region? X goes from 0 up to root y. And so what this will be is this is going to be, well, I'm going to have a 2x cubed, so I'll have a 2x to the 4th over 4 times 1 over y, from x equals 0 to root y. And so what this gives us is this gives us a 1/2, and then this will be an x, this will be a root y to the 4th, which is y squared over y. So this will just be exactly y over 2. And now let's compute the expected value of x given that y is equal to little y. That will be the integral from 0 to the square root of y of x times the conditional density function, 2x over y dx. Now I have 2x squared, so that's going to be a 2/3 x cubed over y. From x goes from 0 up to root y. And so what we get over here is we get 2/3 y to the 3/2 power over y. So this is 2/3 y to the 1/2 power. And so now what we do to find this variance is we can find this variance by saying it's equal to 1, which is y over 2, minus this expression over here squared. So it's going to be a 2/3 y to the 1/2 power quantity squared. And so what this is equal to is this is going to be y over 2. And I'm going to have minus 4 over 9, minus 4 over 9 y. So what we have over here is we've got a common denominator. This is 9 over 18, so this is going to be y times 9 over 18 minus 8 over 18. So our final answer is going to be y over 18 is our variance of x, given that y is equal to y. Thank you very much.